Hello everyone, welcome back. In this video, we are going to go through a packet tracer example where we will set up VLANs in both routed and non-routed networks. So I went ahead and I took the liberty of laying out IP addresses so you don't have to do that. This could also be done through DHCP, but for the scope of this video, we will not be doing that. So the first thing we're going to do, we're going to go ahead and hook up our equipment to the switch. Alright, so once this equipment is hooked up, we're going to go ahead and assign these IP addresses to our computers. Okay, once our IP addresses are assigned, before we set up any VLANs, we are going to attempt to ping these computers to make sure they can talk to each other. Alright, so PC1 can talk to the other 3 computers on the network. At this point, what we're going to do is we're going to enable VLANs on the switch, and we will observe the differences in the network once that's done. To do that, just go into your switch, go into the CLI, and type enable. That will put us in exec mode. This will allow us to execute commands that impact the configuration of the switch. Do configure terminal. And now we need to go into our interfaces, or into our VLAN interfaces. To do this, just do interface, and then VLAN followed by the VLAN number. We're going to use VLAN 10 and VLAN 20. So let's do interface VLAN 10, then you can assign a name to it. So just do the name command, and then type whatever name you want. Oh, well, oh, no, sorry. You just do VLAN 10. This will put you in the config for the VLAN. And now you do name, and then whatever name you want. So I've named mine VLAN 10, and as you see here, it also put it in an up state. This means the VLAN is active. So we'll do the same thing for VLAN 20. You can see it is now in the up state as well. I believe to actually put the VLAN in the up state, you have to go into the interface at least once, and then also go into the config of the VLAN. This will make it go into an up state. So now that our VLANs are configured, we can assign these VLANs to individual ports on our switch. So if you look at my switch, I have connected this PC to FA01. Oh. Okay, it's assigned to FA01. This one is assigned to FA02. This one's assigned to FA03. And this one is assigned to FA04. So what you'll do is you can go into the individual interface that you want to assign the VLAN to. So let's go to FA01, and you do the command switch port mode active. What this command basically does, what this command basically does is it tells the port that it is in an access mode. If you think back to our PowerPoint, an access port is essentially the port that sends the traffic from the network device to its destination. So if I'm sending a packet from this computer to this computer, this would be an access port that would forward that traffic straight through. In a simple network like this, every port's going to be an access port because there's only one network device that everything's connecting to. So let's go ahead and put that in access mode, and then you'll do switch port access, then you do VLAN, and it will let you put the number of the VLAN that you want assigned to that access port. So we're going to put VLAN 10. This will tell it that the only traffic it'll accept on this port, outgoing, will be traffic that's tagged from VLAN 10. So let's do the same thing to this port. Okay, so they are now both in switch port mode access with VLAN 10 as the accepted VLAN on these ports. You can tell because these ports have gone into a, not really a down state, more of a state of reestablishing a connection. So you saw it, that one just turned green, which means it's now active again. So let's go and do the same thing for our other two ports. I'm going to assign these to VLAN 20. Okay, so now these are in that same configuration. So what we'll do now is we're going to test another ping from this computer to the other three. So we're going to ping 10.0.0.2 first, which is this computer, part of the same VLAN. This ping succeeded. Now, if we ping 10.0.0.3, see now that the ping is failing. This is because this switch is only accepting data to that specific port, or to that port from the specific VLAN that it's assigned to, which is VLAN 20. Since this traffic's coming from VLAN 10, it is unable to get to that port because it doesn't accept any other traffic. Now we can view this in simulation mode. If we just run another ping, we will see there's a packet flowing through the network right there. It gets here, receives the frame, broadcasts the frame out, and it sends the frame out to the ports. So it's in here, and this does not match the IP address of this port, so it's failing. Now it's sending that packet out again here. It's not of a service that accepts. Oh, I think that was it. So the request timed out here because it is unable to find a port with that IP address that accepts that traffic from that VLAN. The only port that accepts traffic from VLAN 10 is this port. Since these only accept VLAN 20, it did not send the data through these ports, so the ping failed. Okay, so that was a simple network that just contained one network device, no routing necessary. It was a small network. We are going to move over now to a bigger network that we will be using routing in. So I'm going to, again, I laid out our network information. This one's a little different. We have a big subnet that we've broken down into smaller subnets. Again, I laid out the IP addressing for all these devices, so you don't have to do any extra work there. You just have to configure these devices to use those IP addresses. The first thing we're going to do, though, is we're going to connect up our equipment. I typically always connect the port that goes to the router on the switch to FA024. And I also usually connect it to FA00 on the router. So now that that's connected, I'm going to connect up my machines. It doesn't really matter what ports you connect them to, just make sure that you remember them. Okay. So now that our ports are connected, I'm going to first assign the IP addresses to our computers. You'll notice the default gateways, or the subnet mask, is going to be different on this one because we are using subnetted networks instead. In our previous example, it was one large network, and this one is 3 smaller networks. We are also going to define a default gateway. this default gateway will need to match the VLAN or the IP address of the VLAN that is assigned to the router, since our router is our default gateway. We'll explain how we set this up later, but for now, just for VLAN 10, you'll use 10.0.0.254. For VLAN 20, you'll use 10.0.1.254. And for VLAN 30, you will use 10.0.3.254. So, since this one's assigned to VLAN 10, we will go ahead and type that in. This one's assigned to VLAN 20. It's assigned to VLAN 30. And I put a 3 there. It's supposed to be a 2. I'm sorry about that. I will correct that. Alright, so now all of our ports are assigned to, or all of our IP addresses are assigned to our computers. We have not established any IP addresses or VLANs on the switch yet, which we will do later. The first thing we should do is configure the router though. So to do that, we're going to go into the router, and the very first thing we'll need to do, we'll go into that config mode again, and we need to turn on the port that the router is connected to the VLAN, to the switch through. So to do that, you'll just go into the interface of the port and do a no shut. This will bring the port up, and after a few moments, you will see the link is up. So this is where things get a little complicated. To enable VLANs with routing, you have to use a function of the router that allows you to specify sub interfaces. So basically, instead of 6 computers and 3 different VLANs using one default gateway, they will all have their own sub gateway. Basically, it's like a sub gateway in VLAN, and a VLAN is basically like the gateway of a small network that it'll connect to get to another small network. So let's go ahead and show what that means. So to get into the sub interface of an interface on the router, you just do interface, the name of your interface, which for us is FA0/0, but you'll also do a dot and then the VLAN number. So since I'm going to configure VLAN 10 first, I will do interface FA0/0.10. You'll see now that interface is up, and this means that we can now configure it. So setting up a sub interface is mostly the same as setting up a regular interface on a router. The only difference is you have to do an encapsulation command. So do encapsulation.1q, and then the VLAN number that this VLAN belongs to. So since this is for VLAN 10, we're going to do 10. If it were VLAN 20, you would put a 20 instead. We'll hit enter, and now we can assign an IP address. Okay, so now that we've done that, we can go into our other interfaces, and you'll do the same thing. And now our router is configured. That is all we have to do for the router. I just press the up key on a few of these commands and just change the number. But if you just follow this right here, this is the proper way. This is the proper way to configure a sub interface. Okay, so now that our router is set up, we'll configure our switch to enable trunking and access ports. So this won't differ a lot from what we did on the other network. Go into our config terminal, and we'll go into our individual interfaces that are connected to our computers first. So let's go ahead and go into VLAN 20. And here we will do one more step. We will actually assign an IP address to this VLAN. To do that, you'll just do IP address and then the IP address that you want to assign to it. So we'll do 10.0.0.253 for VLAN 20 or VLAN 10. For VLAN 20, we'll do 10.0.1.253. And for VLAN 30, we'll do 10.0.2.253. We'll exit. We're gonna define a default gateway. This I'm just going to set to the default gateway for VLAN 10. And now that we've done that, we can go ahead and we can actually turn on our interfaces. So remember, we have to do the interface VLAN number first, and then we have to go into the actual VLAN. So now we're in the config of the VLAN, and the VLAN is up. All you really need to do here is assign a name to it. Okay, so now our VLANs are configured. What we can start doing is we can start assigning access ports to our access ports and trunk ports to our switch. So remember, you can go into individual ports. This is FA01 and FA02. And we will do switch port mode access, switch port access VLAN 10. Those ports are up. Then this is VLAN, this is FA03. Or actually, no, this is FA03. This is FA04. We'll do the same thing for VLAN 20, or VLAN 30. And then finally, we have FA05 and FA06. So we'll do thing mode access, switch port access VLAN 20. FA06, switch port mode access, switch port access VLAN 20. Okay, so there's one more thing we have to do. Sorry about that. There's one more thing we have to do. Now that we've assigned access ports to our switch, we have to configure the trunk port between our switch and our router. If you remember from our PowerPoint, a trunk port basically just allows data that is coming from multiple VLAN tags to flow between network devices. So this will allow packets that are tagged from VLAN 10, VLAN 20, and VLAN 30 to all flow between these two devices for routing purposes. So let's go ahead and set that up. So to do that, all you have to do is go into that interface and do switch port mode trunk. So that sets the trunking. So now we have to define a native, we have to define a native VLAN for that trunk. To do that, you'll do switch port trunk native VLAN, and you can choose any VLAN number that you want. I'm going to choose 99. Okay, so now let's go ahead and test the ping. There we go. 001. Okay, so we're going to ping 10.0.0.2. That ping succeeded. So the next thing we're going to ping is the IP address of our switch for VLAN 10, which is 10.0.0.253, which succeeded. The first time will occasionally fail. I think that's just due to it discovering that IP address still. And then the next thing we're going to ping is the router. So as we can see, we have a connection from here to the router. Let's see what happens if we try to ping 10.0.1.1. So you can see here, because we have a router and we have enabled routing, we are able to ping IP addresses that are in other networks or other VLANs on the same network. So we should be able to ping 10.0.1.253 as well. finally 254. And just to verify that it works, we'll do the same thing with the 10021. Okay, so as we can see, a machine that is in the network of 10.0.0.0/24 is able to communicate between VLANs with machines that are in 10.0.1.0 and 10.0.2.0. So we have inter-VLAN networking enabled because we have set up a routing protocol inside of our network. Remember that layer 2 technology does not include routing, so to do this we had to add a router, which works as a layer 3 technology. So that is basically how VLANs work. You can also extend this if you wanted. We are not going to set it up, but to give you a visual example, we could extend this. Try that again. We could extend this and create inter-network routing between VLANs so that we could route from this computer over here all the way to this computer here and these networks as well. So I will create a solution file for this, and it will be included in the description of the video. And if you have any questions, you can always reach out. To the department. You can reach out to me through email, which I'll include in the description as well. But other than that, thank you so much.